Good afternoon and welcome once again Aalto University's public lecture series. And as you know, our theme has been and will be during this autumn 5G. What do we all have to know? And this is actually our fourth lecture this evening. And as you remember well from the previous lectures, we have been seeing and hearing very interesting and very useful issues. And I am sure that that same way will continue this evening. But before going today's lecture, let me remind that you can join this live lecture either via Zoom, and if you want, and please, if you want to ask questions, make comments, then you have to use Zoom. Or otherwise, you can join Panopto, but then the questions are not possible in that way. And to my students, please verify your attendance to this lecture, and you will see soon in both in Zoom and Panopto the code that you have to put, as you know, to my courses. But I am very, very happy to introduce to you this evening's lecturer, who is Marko Lepola. And Marko is Business Development Director in Telia company. And the title of his lecture is 5G Next Steps and New Opportunities. Warm welcome, Marko.
Thank you so much. Great to be here.
So this is like coming to home to you when you are coming to Aalto University. Why, Marko?
Well, Aalto, of course, is the great technology university. And as a former student and also graduating from here, it's great to somehow contribute back, to come back to the kind of same university and see how things have evolved and also hopefully bring something back.
Excellent. And I am very, very happy that you told me before. I will tell you now that you will have many practical examples from the 5G also, that you are not talking only about the theory or the high-level issues, but how it is being used.
That's in real life. That is really my target now. And as the series builds up, you have great presentations from Nokia, from Ericsson, from Traficom, and then you start to hear now the audience will start to hear about the kind of operators' perspectives on this. I think it all kind of cascades and combines it. Maybe we're talking a bit about the same examples because, for instance, with Nokia, we are collaborating very deeply, but I think it's great to have this type of synthesis from the several different views on the same topic.
Absolutely. You know? Please, floor is yours.
Thank you so much. Okay, brilliant. So indeed, today's discussion is about the 5G. And let me briefly tell you how I want to construct this discussion. Let's first start from the perspective of a telecom operator. But how do we come into this discussion? And then let's follow that, start to dive into more and more of the industrial use cases and how the enterprises are seeing all of this development. And I'll promise to really bring a couple of really recent, very real 5G use case examples to the discussion as well. Now, as you know, we are Telia, we are a Nordic operator, and we are very much responsible for the overall digital infrastructure that we have to offer today. So the digital connectivity, the better connected living. And as you see how pervasive, for instance, 4G has become in our society, and when you have had any sort of recent problems with the technology, you realize that we are fully dependent on technology and digital connectivity in our current lives. As Telia, as an operator in Finland and also elsewhere, we of course have a very kind of strong heritage to this topic. We actually can trace Telia's roots back to Russian Tsar's wireless transmission network already. And it just shows that how the technology evolves and somehow companies need to keep up with this development. And now we are also preparing for a very similar jump with the 5G that hopefully will keep adding this type of track record of historical firsts. But when we are really building our mobile future, there are a couple of points. Now 5G is very much available now already in Finland. So we have about 440 cities probably more than 3 million Finnish people can already access the 5G networks. We are very much strongly partnering with Nokia in Finland. And it is very important for us to have a strong, reliable partner for this area, because as you see through the examples, 5G becomes a very integrated, very critical part of this kind of next generation of the society. And then we need to have the reliable partners down the line. We are able to utilize very nice frequency spectrums, as you heard from the Traficom's expert earlier. Finland has been very generous in terms of this allocating these very early, and this is part of the story that we can really utilize and capture here in Finland. Now, 5G is not just about the high speeds and low latencies, but it is also about the possibility for connecting things. So the narrowband IoT LTE networks are also bringing new possibilities for us to build solutions for the perhaps smaller data volumes, but also something that you can really build up the connected things, Internet of Things solutions as well. And as part of this journey, we are also going to do some transitionings away. For instance, 3G networks is something that will now quite quickly be replaced by other technology choices as well. So that's roughly where the kind of key building blocks of this journey are set. But before we go to the enterprise solutions and industrial applications of 5G, let's also look at this a bit from the consumer perspective as well. As a telco, of course, we are then really serving the consumer subscribers with not just with the connectivity, but increasingly bringing in more content and more, for instance, gaming-related things. So, for instance, Telia is very active in the esports arena. We have proud owners of Assembly. We are creating a lot of esports series content, and of course, the Hockey League, C More, MTV3, the kind of content consumption is really critical part of this. And of course, here 5G is also a very relevant piece. At the moment that you want to have really high definition content on your TV, or you really want to, for instance, go seriously for gaming solutions, here 5G becomes also relevant for the consumer consumption and consumer use cases. Now, let's start slowly move to the enterprises side of this discussion. Telia is also one of the key actors towards enterprise customers. We want to be a partner of this digitalization journey for our customers, and we offer the full suite of ICT services. So not just the connectivity, but also compute. And we are, for instance, operating one of the most modern and one of the largest data centers in Finland. This is the Helsinki data center located in Pitäjänmäki, which is kind of a core solution also for the 5G production. Of course, as you all know, the world is not just located here in Finland. We need to connect ourselves to the global cloud platforms, and this is also one of the offerings that we are now able to cater for the enterprise services as well. So 5G now, as I mentioned, it's already available for the 3 million people in more than 140 cities. We have already started also the build-up on the northern and eastern parts of Finland together with the DNA. There we have a shared network set up for that area. And as the 5G rollout goes further, this also means boost and improvements for the 4G network, because typically the 5G rollout also brings in more capacity and more modernization upgrades to the existing old sites as well. And typically we try to build the 5G from the perspective of really driving the customer experience, for instance, building the network in a cluster setup so that whole city is covered in one go. That is roughly the kind of lead up to the kind of telco's role in this from the consumer perspective and also a bit from the enterprise perspective. But now let's start to dig really much deeper into the topics that are perhaps the most interesting in terms of the 5G. And for that, we need to really start from the kind of bigger competitive landscape of Europe. As you know, Europe is now driving a very ambitious strategic agenda in terms of the manufacturing industries. Europe wants to have globally competitive industry and green and digital industry all through Europe. And you can see this drive, for instance, now in the COVID recovery efforts, that where we are spending money, it needs to be green, it needs to be digital, and we are really deploying a vast number of initiatives and programs throughout Europe for really making this leap and boosting this. And 5G is very much an integrated part of this strategy, and it is a kind of enabler for many of the new use cases. So let's get started with this landscape, that what we see as a Telia, but what's really happening now in the industry. I think that there's three parallel things happening. We can see shift in our industrial customers' needs, what they are seeking solutions to, and then we can see a shift in the connectivity and shift in the compute capabilities. And this all together really makes then the attractiveness of the 5G. First, the kind of industrial customers' needs. What's happening really with all of our customers? As you know, manufacturing companies, process chemical companies, they are all running extremely complex industrial systems nowadays. They are increasing the level of automation. They are increasingly focusing on the sustainability, on a circular economy, which drives the need for them to really process vast volumes of data, optimize all of the processes on a totally different level than before. And they also link to very, very highly integrated supply chains. You know that, for instance, any of the small hiccups in the logistics chains will have ripple effects through various industries. Therefore, companies really need to build up their supply chains differently, and also then make sure that they have the needed data analytics capabilities for supporting all of this. The data analytics capabilities are nowadays already a competitive necessity. You can't live without those. And of course, as part of this, you also need to bring in a new digital workforce so that the companies can really take an advantage of the new opportunities that they have. So that's roughly what we see happening from the customer's side as the industry needs. But then the shift that we see in the connectivity is also very fundamental. And this is something that I think that you have been already exposed to in the earlier lectures as well. First significant piece is the fact that we are seeing a movement from the Wi-Fi networks to mobile technology, meaning that increasingly industrial customers are starting to replace Wi-Fi solutions based on cellular or mobile solutions, simply because they need to get more reliability. They need to get into frequency bands that are really controlled and managed. And some of the industrial use cases require different level of mobility that Wi-Fi cannot anymore serve that need. Then we are also able to start to commit to the performance. It means that the mobile technology starts to include enough of quality of service measures or the features in 5G that really guarantee that ultra reliable, low latency communication is possible. Enough mechanisms for really making sure that the bits do get delivered, and there is a constant supervision and quality control of the service that we provide. And also then now the release 16 is about to come out. I mean, current 5G is based on the release 15. That is where the 5G started. It is great for the consumer use cases and for the fixed wireless type of access, but release 16 content will give us a kind of stepwise improvement for some of the really critical capabilities that industrial use cases will need. For instance, more on the ultra low latency reliable communications area for the network slicing, positioning of things in the radio network, especially for instance when you need to position things indoors, and then time synchronization, so that industrial automation systems can really rely on mobile technologies as a base. It's interesting to look at who are the companies who were defining the release 16 content. If you look through that specification, who were the companies who really contributed, you'll find all of the great industrial automation houses, Siemens, ABB, others, who were very actively part of that specification. Now, connectivity is great, but it's in isolation, it is pretty useless if you don't have new means for really handling and managing the content and doing something useful with the bits. So the shift in compute is also equally very, very important. You know that there is already large-scale transition to cloud paradigm, that we are able to process the data using the great big cloud platforms Google, AWS, Amazon, Microsoft Azure. And as part of this cloud-native paradigm, it's also something that industrial customers are taking this into use, starting to combine those capabilities with the 5G networks. But besides the cloud paradigm, the edge paradigm is now coming up very quickly. For those applications where you really need a super low latency, you need to react within a couple of milliseconds, the only option is to really bring the edge compute capabilities in, but that also links to the cloud paradigm as well. So they will work jointly in tandem. AI, machine learning algorithms also coming from the compute, and most of the use cases that we'll soon go into are actually somehow based on the fact that we can now really bring in different type of video analytics routines or much more independent decision-making models for the machines. And that is all given to us by the AI machine learning type of capabilities. Now, we're also seeing a very much big steps and developments in how graphics is actually being produced. So GPU optimization, what type of low latency creation can you make for AR and VR applications? Partially coming from the cloud or from the edge compute solution, but this is all kind of linking to the compute capabilities that we can now build the solutions from. And as this all links then together to the volume of data that the companies are creating, data models are coming up so that the kind of exchange of industrial data between the companies becomes possible, and it's easier to build a kind of analytics application if you have shared data models. So this is turning truly into a platform and ecosystem play. So the idea of these three shifts, we can see that the customer needs are changing, there's a shift in connectivity, and there's massive shift in compute. All of this then starts to bring in kind of very interesting capabilities on how the future looks. And if you're interested in looking a bit deeper into this, there's one publication that would be kind of my recommendation to read through. It's actually VTT's publication. VTT is a research agency here in Finland. They have published a vision paper about the cognitive manufacturing topics, cognitive manufacturing vision for the manufacturing industries. And that paper is a very well-written, crisp explanation on how this is going to happen in the coming years and how the different technical components or solutions will all come together. Now, let's then start to look at this from Telia's perspective and then slowly driving towards the actual use cases and examples. The first part of this is that during this lecture series, somebody either has or will show you the classical 5G triangle, meaning that 5G gives you the enhanced mobile broadband, the gigabit speeds, it will give you the massive volume of connectivity, for instance, for IoT sensoring that are using very much low energy. And then you'll have the right-hand corner where you have the ultra reliable low latency communication solutions. The first part of the triangle is something that we can easily use for strengthening the existing services. And the lower part of the triangle is something that really gives a basis for us to innovate new services. The first phase of strengthening the existing services, this started pretty much from the beginning of 2019 when the commercial licenses were granted. Today's focus from Telia's perspective is really on moving, also utilizing the higher frequency bands, so 26 gigahertz band, the millimeter wave band, and also starting to deploy and use 5G in the standalone configuration, meaning that we are not anymore relying on 4G networks, but 5G SA gives you even better latency and gives you more capabilities, for instance, for the slicing. And later part of this discussion, I'll also show a couple of actual customer deployments that are already 5G SA deployments. So the focus is slowly moving to the more and more kind of industrial use cases. But let's cover still a couple of the proof points from the phase one. So what does this really mean in practice? As I mentioned, Telia has the interesting position that we are operating in all of the Nordic countries and Baltics. But Finland has been truly generous in terms of the frequency allocations. We have all of the possible 5G bands now available for building these solutions. And therefore, I can show you, for instance, fairly interesting snapshot of from the last summer, so summer of 21. This is one of the millimeter wave base stations that is integrated to our public network. The measurement point here is about a bit shy from a kilometer away from the base station. And if you can see in the screen, you can see download speeds of 3,500 megabits per second. So 3.4 gigabits towards downlink speed or downlink direction, and uplink 250 megabits per second. So this is truly kind of new era of the capacity that you can build from the 5G use cases. Especially the uplink direction is very interesting because increasingly many of the industrial use cases are really uplink heavy. They are using video analytics or some other forms of data creation that really puts much more emphasis on the uplink speed than what you need on the downlink side. Another example of the top part of the triangle is the fact that 5G is now becoming part of the enterprise networking solutions as well. This is from our Future of ICT event from this autumn, where we were introducing the fact that now you can use 5G in the enterprise networking as a solution component. So the fixed wireless access, you have a 5G modem external box that you directly link to enterprise networking solutions, gives you a lot more flexibility and access and possibility to, for instance, move your points of presence or your offices very much more easily around than before. And it gives you extremely attractive capacity and latency figures as well. But now let's start to delve in to the kind of lower part of the triangle, and let's pick up specific use cases and examples where we can really demonstrate what the 5G is really useful for. And we have been running these across the Nordics, so some of these examples are from Sweden, some of these examples are then really Finnish cases as well. And let's pick the first use case here. So this is actually a use case from Boliden Harjavalta. They are metal processing plant, smeltering operation producing nickel. And as part of the process, they actually need to carry the residue of the metal making process, the basically molten rock, away from the smeltering operations. So they have these very large industrial grade trucks that are carrying these pots over to a cooling area. And now that shipment or that cargo is extremely dangerous. It is basically lava, molten rock. So you don't want to spill that. Where does the 5G come into this? Because you obviously need to have a very good control of all of the operations. A very simple 5G solution is the fact that you put in high resolution cameras for this truck front and back, connect them to an industrial router, to a 5G network, drive the data feed or the video feed into the control rooms of that site, and you start to have a very different control in terms of situational awareness. And if something happens, you have immediately eyes on the ground seeing what has happened. But when you have that data available, it starts to trigger you much more other use cases that you can actually build more on top of the video analytics capabilities and more use cases based on a relatively simple first step. But this type of steps are now actually going into the production as well. Then let me pick up another example. This is a 5G ride. This is actually in Stockholm. So it is autonomous minivan that can be remotely controlled when needed. It is been in a couple of testing cycles in operations in the Stockholm area. And this is really kind of one of the first larger scale deployments of autonomous buses. Of course, we have seen something like this in Finland as well. But this is a good example of really bringing this into an actual use and also connecting the autonomous operations and remote operations into a joint flow. Then let me introduce a real killer robot. So this is one of our projects in Sweden, where we are developing and testing an agricultural robot. And the killer part comes from the fact that this robot has this type of knife or scissor type of implements that it can use for cutting weeds. So basically, you can start the farm without using any pesticides. You're actually mechanically removing the weeds and making it work that way, much more sustainably and more environmentally friendly. And the 5G comes from the fact that, of course, the robot needs to know what to pick, what to kill. And there, the video analytics use case here is built into the solution, and it is partially edge capable or edge compute based and partially cloud compute based setup that we're looking at here. So bringing this type of test and trials where the 5G is actually used in actual context, this is actual an onion field in Sweden where this is in operations and running. Now, let me then pick up a couple of more local examples, and let's spend a bit more time opening these use cases as well, that what 5G is really useful for. My next example, let me introduce to you a robot called Taika. This is actually a use case here in Finland, in the shopping mall Tripla, where we have been running this type of robotics experience now during this July and now in October. And what this concept is all about is that it is actually a food delivery robot. So there's in the original test cycle in July, there was a couple of restaurants where you can order food deliveries, and the robot is capable of independently delivering these from the food court area of the Tripla to the hotel guests quite independently. And the idea of this type of development and testing is that this is actually done jointly with great number of companies as use case, supported by Business Finland, and then we have the participating companies listed here. But part of this type of robotics development is actually much wider than getting you some food delivered. Taika is actually an edge computer. It delivers you the burgers, but it actually is also capable of doing quite a bit more than just acting as a delivery robot. And Taika is actually linked to a much bigger development activity. So Telia, jointly with VTT and a couple of other companies, is driving a project called Muro, Multipurpose Service Robotics. And the idea of the Muro is that it actually starts to look at the service robotics differently. So first of all, building service robots to be multi-purpose robots so that each robot would have more than one function, that it would be able to deliver a wide range of use cases. And also, the other part of the program is to change the way how this works commercially, so that how you actually buy the robotic services, instead of just buying a robot, you would turn that into a services business. But also, this program is testing the kind of use of fleets of robots, that what a fleet of robots could do instead of individual robots. This is a multi-year project that will test other use cases than this Taika robot as well. But let's also then pick up a couple of other points on this specific example of food deliveries and what is a multi-purpose use case in the context of a shopping mall. Now, obviously, shopping malls have a great number of different types of indoor logistics and delivery related tasks. There is a lot of goods that are shipped between the shops, and how shops are restocking their supplies and what type of deliveries can you make to the consumers within a shopping mall. But there's also needs for the guidance and hospitality, that what could service robots do more in that area. Obviously, shopping malls also will need the safety features so that it is a safe experience for the consumers. We can build more kind of capabilities around the safety use cases, but there's also quite a lot of facility services, facility management related tasks that you can actually give to a robot. For instance, observing any sort of spills or trashes, or assisting the actual building related repairs or observations or insights. And of course, all of the shopping malls, they live from the footfall analytics, that where are people visiting? Are there crowded areas? how is the kind of movement and feeling of the experience as you are there in the shopping area. And for this type of case, it needs to be really a safe topic. It needs to respect your privacy. It needs to protect the data that is being generated from this type of experiment. And of course, this type of projects actually really drive the robotics development as well. So let's look at some of the reactions that we got from this type of testing. One of the key testing elements was that will people actually accept service robotics in a public space? Because we don't yet see these in great numbers. And in this experiment, I'm happy to report that it was an overwhelmingly positive reaction, that the people in the shopping mall really accepted the fact that, okay, getting deliveries through the shopping mall based on a robotics platform seems to be perfectly fine. And especially kids were really kind of eagerly accepting and making the point that this is perfectly interesting and acceptable as a use case. And of course, we need to be able to move within the shopping mall. And this specific shopping mall is actually equipped with the very modern elevators from KONE. And now on this project, we have developed an integration that the robot who doesn't have arms is actually capable of ordering and using the elevators throughout the shopping center, so that it actually can get from the food court area by using 2 different lifts into deliver the foods to a hotel guest. And this is part of the 5G attractiveness, that it really starts to create the software ecosystem as well. That even though Taika is an edge computer, it actually can access quite a range of different systems that are cloud-based. And for instance, ordering the lift is then a software API call to KONE elevator. And I also mentioned that these are really kind of multi-purpose cases. So one part of this exercise has been really to build up video analytics capabilities for this robotics platform. I mentioned that the footfall analytics is something that the shopping malls are very curious about. And now this specific example gives you a case where the robot is actually able to make observations about the humans. It doesn't detect you as a person. It doesn't do facial recognition, but is capable of counting humans or persons and their movements in the shopping area as anonymous data sets. And that can be then used, for instance, for helping with the traffic control, or helping with the placement of different type of things in the shopping mall, or for instance, seeing how the queuing situation in the food court area is developing. So being able to generate data by the means of video analytics that is useful for developing the shopping experience and the shopping mall business case further. The way it works is that the robot has an on-top camera that is looking through all of its surroundings, and then it's making the detections of human shapes, creates those in the data points, and gives us plots of how the people were moving in specific area while the robot was passing through. So that is a kind of a consumer-centric example of 5G use cases. But now let's pick up a very different story, and let's go do some gold mining. And let's build up the very different use case from the really true kind of industrial giant. So Telia, we actually have a fairly long reference list for different type of mining related cases. We have been delivering private 4G based networks to several of our customers. For instance, Lundin Mining with their Zinkgruvan mining site, or Boliden Aitik in Sweden. And of course, the 4G gives you already certain capabilities that you can really start to bring in the first remote control solutions, and you can really start to, for instance, do different communication and connectivity for the miners themselves. But this is a story that is going to have a slightly different angle when you turn into 5G capabilities. And for that story, I want you to take to Agnito Eagle mine in Kittilä. So this is actually Europe's largest gold mine. Agnito Eagle's case is such that it started as an open pit mine, and when somewhere in the mid-2000, they actually moved into mining operation that they started to go underground. So really tunneling down deep into the ground where the kind of most richest gold deposits are. And at the moment, that mining operation is at the depth of 1 kilometer. So 1 kilometer below ground. And that is actually, if you start to think about it, it is quite a remarkable depth already. But if you think about the typical ceiling height is 3 meters, 10-story building is then 30 meters, you're at the depth of 1 kilometer. So it basically starts to mean very many things from the technology perspective. First of all, it takes very long time to commute. If you need to get people the bottom of the mining shaft really for the operations, that actually is a very time-consuming task, just to get there where you're supposed to work. Another part of this mining exercise is that if you are running traditional mining equipment, you are using combustion engines, so you need air. The humans will need air, but you also need to have air and oxygen for the engines to run, but so you need to ventilate the mining shafts as well. So you need to pump in a volume of air down, and you need to get all of the exhausts away as well. That starts to be complicated when you are at the depth of 1 kilometer. And of course, mining is inherently very dangerous operation as well. So you need to be able to kind of make sure that it is a safe operation. So what we announced actually last week is that we are now together jointly with Nokia, we are building a private 5G network for this mine, and which enables them to really then, for them to take the next steps of the digitalization, that they will be able to really automate the operations much more than ever before. And this is actually then kind of a possible view that what perhaps could be operating in their mine down the line. So this is, for instance, Sandvik's mining concept, what they have introduced, that it is a mining vehicle that is fully electrical, and to a very large extent, it is already fully autonomous operation. Of course, there's also remote control to support the automation as well. But the mining industry is moving into this type of use cases where it is the kind of the private networking, the 5G network becomes really the core of the operation, that it really needs to support the automation, and that helps us to really take the next steps of the efficiency and digitalization. So that starts to be the kind of most part of the presentation. So I'm trying to give you a perspective that the ambitions that we have in terms of really driving the 5G, to use it for strengthening the existing services, we can really see this type of gigabits in a world coming together. And we start to see the lower part of the triangle as well being filled with actual use cases of really driving different types of mobile robotic solutions in the mining or elsewhere, even in your nearest shopping mall. We start to have more and more of the autonomous systems, and we start to see a lot of the factory use cases emerging where, for instance, logistics or production quality monitoring starts to happen based on the 5G networks. That's roughly the kind of prepared content that I wanted to share in terms of the next steps and then the new opportunities to really bring in the perspective on where we are now, what's happening, and then you can start to see from there where this industry is going next. And I hope and I believe that we are supposed to have a couple of debates and questions and follow-up questions on the topic as well. So.
Thank you very much for the presentation and the lecture. And I can really see, and I think everybody can see that you are very excited about the 5G.
Indeed, we are.
What is the most exciting thing about this?
Well, the technology itself, of course, is interesting, but that's not the exciting piece. The exciting piece is actually the one where we can really put this into good use. Yes. That the 5G is actually delivering value that we couldn't do before. For instance, think about the killer robot there, transforming the agricultural processes of really taking the weeds out without chemicals, or the safety that we can bring in for the smeltering operation, or then the fact that we can really continue mining at the depth of 1 kilometer, and then really make it much more convenient and much kind of safer and better environment for the human to work in that setup. So it is the application of the 5G that really brings in this type of exciting pieces of this journey.
Very good. Hey, what would you say when we are thinking about like a normal people who are not doing on daily basis any mining issues or something like that, how their life will change with 5G?
Well, the normal people, and of course we are all normal people, I think it is something that you start to see it from different use cases. First of all, the consumer-centric use cases of gaming, that is a kind of obvious one, or the more of the content uses. That, for instance, when we go for the 4K or 8K TVs and in a way high definition entertainment, 5G brings in fixed wireless access, gives you kind of very simple use case for that as well.
Yes.
But what I showed about the service robotics is also actually something that it may be coming much faster than we think, that we'll actually start to bring in service robotics also for the normal people, that you can get home deliveries or you can get service robots that would help you on your daily tasks as well. In Finland, we don't see those much, but if you go to Japan, South Korea, you see a very different approach to how widely service robots are being applied. And that's why it's very good time for us to start acting on those as well. So it is very likely that you will find, as an average, normal, everyday person, you'll find also this type of 5G enabled use cases quite close and quite soon.
So I can guess now that the Telia company's strategy is going towards these home robots. Is it so?
Well, home robots is part of the thing. And of course, this specific example is also that this is also a way of framing the development questions.
Yes.
That you build up a kind of interesting test setup and you use it in a real life usage scenario to figure out how does this really work. For instance, the fact that how do you get the robot to travel in a lift or an elevator? Okay, it sounds simple, but it actually requires quite many steps before it is really possible to bring a robot that moves in a crowded shopping mall full of people.
Yes.
So that's also the part of this that this way we really can build the capabilities and test them and bring them into kind of the maturity point that they then can be really deployed.
Good. Hey, let's go back to Kittilä. Here is a question from Henrik Stark. Will the Kittilä mine have a SA network, and what frequency is best for mining purposes?
Okay, that is a very interesting question. I believe that he may know something about the technology. It is indeed an SA network. So it is a 5G standalone network, meaning that it doesn't need the 4G support for this. Now, the exact frequency allocations, that may be something that we are not publicly disclosing, but the mining tunnels are interesting ones. Radio waves don't make sharp turns. So you need to really build up kind of different antenna solutions and then really utilize the kind of wide spectrum available that you can really deploy on this as well. But now in this case, we are really committing to building a very, very long network along the corridors of this. And to add to the criticality, the mining operations is great, but they have also extreme environmental conditions. And for instance, these guys insist on blasting every now and then, actually quite often. So it is drilling and blasting operation. So bringing electronics into an area where it's always part of the shock waves is also part of the design. So there are some specific considerations in the mining solutions as well.
Yes. Good. Another question concerning about the mine from Martin. Could you elaborate on the Kittilä mine's private networks topology? How is the network built out in such a demanding environment? Well, you a little bit.
I think we partially covered it as well, and of course, this is something that we are not able to disclose all of the design details of this. But
yes, but we will continue with Martin's question. Has the Taika robot testing inspired new similar endeavors you might be able to share with us?
Actually, it has, and let's also bring Taika back here as an example of this, because this is something that we typically see also in this type of use cases, that when you bring an experiment like this to public domain, you start to actually get feedback from all of the surrounding people quite quickly. So when Taika was moving in Tripla, actually we were contacted by a lot of people in Tripla that, okay, our company would have this type of use case. Could the robot support it as well? So this type of,
what kind of use case?
for instance, especially for instance, well, that is a simple add-on, what we have already discussed, but the deliveries.
Yes.
There were a lot of parties who we didn't know that actually had so many different deliveries that they would like to run through the shopping mall that we hadn't identified in the desktop work. Or then the other area of innovation, for instance, is that somebody sees this robot and asks to convert it for their use case. We have one industrial customer who saw this and said that, okay, if you lose the kind of nice eyes and all of the tapes, I could actually turn this into a mobile toolbox in my industrial plant. But I would need to have a well-stocked kind of mechanics toolbox and ability to fetch spare parts from my central deposit. So basically it's the same use case, but then somebody applies it into their surroundings. I mean, shopping mall and industrial site doesn't have too much in common, but this way they actually start to traverse or move around the different industries as well.
Very good. One very important issue about the 5G as well in general in technology is the role of security. What are your thoughts about the security when you are thinking about the 5G and the future and different applications about it?
This is actually the kind of the paramount piece of topics that we need to cover in all aspects of the security. One of the, I mean, this is, of course, as I'm speaking to you, I'd say it's kind of obvious that the cybersecurity topic is there, and it needs to start from the very design of things. What are the risks that you are preparing for, and it is also the whole development cycle that because many of the systems are hacked actually not in the operational phase but already in the development phase. You need to bring this type of pervasive kind of security thinking for the design process as well. And I don't say that these would be unhackable. Nothing is unhackable, but you also need to prepare for the eventuality that something would not work, that you need to also have a backup plan for these solutions then when it doesn't work, and also the recovery operations as well. So it is very kind of large scale topic to be addressed, and I'm sure that there are other good lecture series covering it, but you need to bring it in all through the design and thinking process. 5G itself brings, of course, additional security features in terms of the how you authenticate and how reliable the transmission will be. But of course, the fact that you have more capacity available, you can also then bring in additional safety measures for the data transmissions that you use. And also the fact that you can combine this with edge processing, that you don't need to transmit everything. You can also combine the 5G solution to compute setup that is very much local. And that eliminates some of the risks that you would have from the cybersecurity perspective as well. Of course, it may bring in additional ones, but by design, it can help.
Good. Hey, last question. When I was listening your lecture, I paid my attention that you told actually in quite many places that you are doing partnerships, even with some of your competitors in a way. So my question is that how much you can do in 5G, you are from the big company, from Telia company, how much you can do by yourself and with others?
No, the partnerships is a really critical part of all of this development. And Finland specifically is actually very unique in that sense that here the companies can find each other's. And this is something that we should really kind of use as our strong point, that we can set up this type of collaborations where this really starts to happen. And many of these areas have kind of such a deep domain expertise that is needed. Obviously, Telia is not a mining company. We will never be kind of experts in the mining business on how that works. So you need to build that as a kind of a collaboration of the different companies who have then combined have that expertise that is needed. Now, what Telia can do, of course, the kind of connectivity is what we deliver, but the connectivity is also then quite rapidly kind of starting to incorporate the compute part as well. So we are able to deliver that part as well. And of course, all of the device management related topics comes quite naturally to the telco domain. And very importantly, the managed services part. because somebody needs to look at these solutions when they operation. And here, telco's capabilities to monitor and run service assurance are actually quite relevant for many of the industries.
Yes. Thank you very much. Excellent lecture.
Thank you so much.
And hopefully you are visiting Aalto in more often in the coming years as well.
Indeed, I will.
And then, as I think we can all agree that when the title was, as you can see, the 5G next steps, and especially the new opportunities, you really opened the new opportunities. And I think pretty many of us are thinking that what are the concrete results, what we are getting from the 5G, and you brought that up very well. So thank you once again. We will finish this evening's lecture this time, and we will get back next time with next lecture. And the theme is 5G. What do we all have to know? Thank you very much.